let's explore a few more concepts in graph theory, right. So, the next concept is adjacent. So, two vertices V and W of G are called adjacent if there exists an edge between V and W, right. So, in this graph we say this edge and this edge are this vertex San Francisco and this vertex Denver are adjacent to each other because there is an edge between both of them, right. So, the concept is about adjacent. Two vertices are called adjacent if they are having at least there is one edge, there exists at least one edge between those two vertices. Same way we have adjacent edges. What is that? E1, E2 are two edges, they are called adjacent edges if there is at least one common vertex for both of them. It means I have V1, I have V2, there is a vertex V3. So, this is my edge E1, this is my edge E2. See, E1, E2 are adjacent to each other because there is one vertex which is common in both the cases. There is one vertex which is common for both the edges. So, these kind of edges are called adjacent edges, and vertex V1, V3 are called adjacent because there is a edge. So, V1, V3 are adjacent vertices, V3, V2 are adjacent vertices, right. So, you can tell that based on that. The next one is incident. We say a vertex V, whenever a vertex V is an endpoint of some edge E, then we say that E is incident with that vertex V. E is incident with that vertex V and V is incident with that edge E. There is an edge like this with vertex V1 and V2, there is edge E1. Then we say what is the endpoints of E1, V1 and V2. Then we say that E is incident on V1 or V2. Same way V1 is incident on E1. So, whichever edge and vertex are related, then we say they are incident to each other. With this concept, we have something called incidence table. What is incidence table? Listing down all the edges and the vertices which are forming those edges. See, listing down all the edges in the graph and the vertices which are helping in forming that particular edge. For E1, V1, V2, it means if I have a graph, okay, so let us try to draw this. So, it is very clear that vertex V1, V2, V3, V4, V6 are there. So, let us draw 6 vertices. Okay, so this is V1, V2, V3, V4, V5 and V6. See, V1, V2 are forming E1, V1, V2 are forming E1, V1, V2 are again forming E2, multiple edge. So, there is another edge like this E2. Then V4, V3 are forming E3. Then V6, V3 are forming E4, V6, V3 are forming E4. V2, V4 is forming E5. So, these are connecting like this E5. Then V6, V6 and V3 anyhow they are connecting. So, there is another edge like this E6. Okay. So, what is this incidence table? Incidence table helps us in drawing the graph, or a graph can be written as an incidence table. What is this? Here we give the edges and we also give the vertices which are forming this edge. If you can write such kind of a table, that is called an incidence table. Okay. The next concept here in graph theory is that isolated vertex. And a vertex is called isolated if it is not incident with any edge. A vertex is called isolated if it is not incident with any edge. It means, see, I have two vertices V1, V2 and there is an edge E1. See, we are saying that this V1 is incident on edge E1, V2 is incidence on edge E1. But if I have a vertex like this, there is one edge E1 between V1 and V2, but there is V3. V3, does this is this V3 incident on any edge? No, there is no edge with this using this V3. Then we say these kind of vertices are called as isolated vertex. They are called as isolated vertex. Okay, right? And the most important concept is degree of a graph. Right? So, what is degree of a vertex V? Generally, we find out the degree of a vertex or vertices. What is this degree of V? Number of edges Okay, if I take a vertex v1, number of edges incident with this v1 is called the degree. Number of edges incident with this vertex v1 are called degree. It means in a graph I have a node v1. It is connecting with v3 and forming one edge e1. It is connecting with v5 forming an edge e2. So v1 is incident with how many edges? Two edges, e1 and e2. So its degree is 2. Its degree is 2, right? So what about degree of isolated vertex? Like this, if I take a graph v1, v2 and v3, what is degree of v1? In this small graph, what is degree of v1? It is incident on one edge only, so 1. v2 is also incident on one edge, so it's also 1. v3, it is not incident on any edge, that's why it is 0. So this number 1, 0 are the degrees of vertices v1, v2 and v3. Okay, this is very important concept. Let's see that in detail. Okay, for undirected graph, there is only one degree. Let us go and find out degree of this graph, undirected graph. Maybe I'll take this example. Okay, let's find out the degree of the vertices in this graph. So San Francisco, see how many edges is it incident with? 2 edges, so its degree is 2. Los Angeles, again degree is 2. Denver 1, 2 and 3. Chicago, you see 1, 2, 3, 4. Okay, again Detroit 2, New York 1, 2, 3. Okay, Washington 2. So these are the degrees of the graph. For an undirected graph, it is very simple count. Number of edges connecting to that vertex is called the degree of a graph. That is for undirected graph. What about directed graph? For a directed graph, we have 2 degrees here, because it is having some direction. So we have 2 parameters here, in degree and out degree. In degree and out degree. What is this? Number of edges going away from a vertex is the out degree. Number of vertices coming towards that vertex is in degree. See here, again I will talk about loop. What about loop? When there is loop, what we have to do? Right, if it is undirected graph, maybe this example. If it is undirected graph, what is the degree of this vertex San Francisco? Let us count. Let us see the degree of San Francisco. How many edges is it incident with? See, 1, 2 and 3. Why am I saying 3? Here from San Francisco there is one edge going and coming back to itself. It means there are 2 vertices. It means there are 2 edges. It means there are 2 edges. One is going away from San Francisco, other is coming towards San Francisco. So in a undirected graph, when you are counting out the degree in an undirected graph, when there is a loop, you have to increment to 2. You have to consider the count as 2, not 1. So for San Francisco, the degree of this node San Francisco is 1, 2 plus this 2, total 4. Okay, what about this Denver? You see 1, 2, 3, 4, 5, 6 and plus 2, 8 is the degree of this Denver. Okay, so when you count the degree of a vertex for an undirected graph where there is no arrow mark, then if there is a loop, you have to count it as 2, because it is both way, right? One is going away, other is coming in, that way. But whereas for directed graph, we have 2 things, in degree and out degree. Okay, so you see here, from A, in degree count. What is the in degree count of A? What is the in degree count of A? How many are coming towards A? See, 1 is coming towards A, so 1 plus. See, from E, another one is coming towards A, 1 plus. Is there anything else coming towards A? No. So the in degree of vertex A, is 2. In degree is 2. What about out degree? Out degree of vertex A. See, from A, 1 is going away, self loop. You have to count it 1 here. So you are splitting that 2 count in undirected graph, 1 to in degree, 1 to out degree. If there is a directed graph and there is a self loop, then the in degree will be given as count 1, out degree we have to take it as 1. Okay, now let's find out what is out degree of this vertex A. How many vertices are going away? So this is 1 going away, this is 2, this is 3, this is 4. So the out degree of vertex A is 4. See in the graph, right? So given a graph, What is the in degree, what is the out degree, you have to find out. Let's do it for E. Let's do it for E. What is the in degree? What is the in degree of E? In degree of E. So how many are coming towards E? So self loop is there, I have to count 1 plus, you see, this is coming here 2, this is coming here 3. So it has total in degree of E is 3. Now what is out degree of E? How many are going away from E? So self loop means it is going away. So that is 1. See here from A it is going away. This is 2, and to D it is going away. It is 3. So the in degree of out degree of E is 3. Okay, based on number of arrows going away and coming in, that you have to count. Only thing, when there is a loop, you have to count as 1 in degree and also 1 in out degree. Okay, so this is about finding out degrees of a vertex in a graph. If it is undirected graph, you have to just count 1, 1, 1. If it is a directed graph, then you have to find out 2 separate values, in degree and out degree. Next, few more graph terminology, right? Let G be a graph and K be a non-negative integer. Let G be a graph and K be a non-negative integer. G is called K regular graph if the degree of each vertex is K. G is called K regular graph if the degree of each vertex is K. It means I can say, right, 4 regular graph. I can say 4 regular graph. Means the degree of each vertex is equal, that is 4, 4, 4, 4. Okay, we say it as a K regular graph, right? Next, the set of all neighbors of a vertex are called the neighborhood of V. What is the neighborhood of V? When can we say they are neighbors, right? Set of all the neighbors of a vertex V are the neighborhood. So what is neighborhood here? Here for this graph H, for this graph H, what is the neighborhood of A? Neighborhood of, for A, the neighborhood values are E, B, D. It is E, B and D, because these are the neighbors of A. When we say they are neighbors, because there is an edge from A to E, from A to D, from A to B, there is an edge. Then we say they are neighbors of A. Now, a vertex is called pendant if its degree is 1. A vertex is pendant if its degree is 1. See this vertex D, its degree is 1. Why? It is incident with only one edge. It is incident with only one edge. That's why the degree of node E is 1. Okay, such kind of vertices for which the degree is 1 are called as pendant vertices or pendant vertex. See here, C is a pendant vertex because the degree of that vertex C is 1. It means it is incident with only one edge. Okay, so this is about few graph terminology. We have some theorems in graphs. So let us see, again so many points are there, we will try to explore them, which are again based on these number of things. What is this handshaking theorem in graph theory? Handshaking theorem, very popular theorem. It says that let G be an undirected graph. Let G be an undirected graph, then okay, then with m edges, then 2 into number of edges. 2 into number of edges is equal, will be equal to summation of degrees of all the vertices. Summation of degrees of all the vertices. Okay, let's see this, what they are telling here. If there is a graph, let me take a graph, let me draw a small graph here. Okay, so let there be one edge, let there be another edge like this. This is a small graph. So these are the vertices here. Okay, how many edges are there? See, E1, E2, E3, E4, E5, E6. So number of edges is 6. It says that if I know the number of edges, then 2 into m, double the number of edges, the sum of degrees of all the vertices will be equal to double the number of edges. Let's again verify that. So you see this node, what is the degree? 1, 2, 3, 4. This is 4. What about this? 1, 2. This is 2. What about this? 1, 2, 3. This is 3. What about this? 1, 2, 3. This is 3. Now you count all the degrees of this graph. That is 4 plus 2 plus 3 plus 3. This is 12. So it's very clear that number of edges into 2 will be equal to, it will be equal to the sum of degrees of all the vertices. That is handshaking theorem. Okay, handshaking theorem says that if there is an undirected graph with m edges, then 2 into m will be equal to summation of the degrees of all the vertices. Okay. So, there can be some problems like this. How many edges are there in a graph with 10 vertices, each of degree 6? There are 10 vertices, each of degree 6. So, 60. So, I can write 2m equal to 60. Sum of all those degrees is 60. Now, what is m value? 30. It means there are 30 edges in that graph. Okay. Next. Again, these are simple things, initial vertex and end vertex. If u comma v is forming an edge, if this is forming an edge E1, u is called initial vertex and v is called end vertex. This is called end vertex and this is called initial vertex. Okay. So, these are few terms, we will be always using them in graph theory. So, few principles or theorems, I would say, we would say graph theorems. Okay, though they are again part of graph terminology, right? An undirected graph has even number of vertices of odd degree. There are few theorems. An undirected graph with even number of vertices, let us take 4, will have an undirected graph has an even number of vertices of odd degree. Same graph you see. I am drawing a graph. I said there is an edge like this and there is an edge like this. It has even number of vertices of odd degree. See, this degree is 4, this degree is 2, this degree is 3, this degree is 3. See, how many vertices are there with odd degree? 3 and 3. There are 2. That is even number. That is what this theorem is. Second, sum of degrees of all the vertices of the graph is twice the number of edges. Our handshaking theorem. Our handshaking theorem. Next, sum of degrees of all the vertices of a graph is an even integer always. See, 4 plus 2, 6 plus 3 plus 9 plus 12. Sum of degrees of all the vertices is always an even integer. Okay. Next, in a graph, the number of odd degree vertices is even. Odd degree vertices is even. That is what the first one is repeated again. So, odd degree vertices are 2, that is 2, that is even number. Okay. So, these are a few concepts in graph theory. We will be exploring more about some theoretical concepts of graph. We are learning so many concepts of graph theory, then we will go for problems. We need to understand all these basics. What is incident, what is in degree, out degree, degree of a vertex. Okay. Then we have to understand about the what is an initial vertex, end vertex, so many concepts. So, we are trying to learn different concepts of graph theory, then we will go and apply and solve the problems. So, in the next video, we will be solving some more, we will be learning some more theoretical concepts of graph and then we will go for problems. Thank you.